Okay, we're going to go over midpoints of the sides of a triangle. Okay? So, question is, in triangle ABCD, which is this point down here, is the midpoint of side AC. This is A, this is C. I should write those in, just so you know. We'll look at it after. And E, which is down here, is the midpoint of BC. Question A says, verify that line segment DE, that's this line, is parallel to side AB. And we'll zoom in so we get a better look of what we're talking about there. Since this was our A, B, and C, the question asks us to verify that the two midpoints, which are DE, are parallel to AB. Okay? Well, they've drawn this on the graph, and it looks like the points are at a specific part here, but we actually have to find what the midpoints are before we can say. Okay? By looking at the graph, it looks like this is probably at 4 and 4, and that this point here is probably at 6 and 3. Okay? But since we are not 100% sure, we need to find midpoints to start. So, if you guys recall, our midpoint formula is X, M, Y, M. If you remember it, you don't have to write it in every time. And we take X1 plus X2 divide by 2. And the other part of the formula is Y1 plus Y2 divided by 2. Okay? So, now that we have that information, we're going to find the very first one, which is AC. Okay? We'll do that one in red. So, point A, which is at 1 and 3, and point C, which is at 7 and 5. We're going to use these coordinates to find the midpoint D. So we'll call this coordinate 1, so x1, y1, x2, y2. Okay. So we have that information. We'll do this in red. We know we're going to add the two x values. Well, the x values are 1 and 7. And then we'll divide by 2. And then we take the two y values and add them. Those values are 3 and 5. 1 plus 7 will give us, divided by 2. Good. And 3 plus 5 is divided by 2. So midpoint D is at 4 and 4, which is exactly what we assumed it would be. Okay. We also need to check BC. Okay. So this is exactly right. We're going to check BC. Well, B was at point 5 and 1. And C was at 7 and 5 again. Now, we don't need to rewrite this formula. We'll do this one in green. We already know the midpoint formula, so I'm just going to carry it out. We add the two x values, which are 5 and 7, and divide by 2. And then we add the two y values, which are 1 and 5, and divide that by 2. 5 plus 7 is 12 divided by 2. A 1 is 6 divided by 2. So we get 6 and 3. Which is, once again, exactly what we had up here, 6 and 3. So now that we have those coordinates, it says to prove that they're parallel to AB. In other words, we need to find the slope of AB and we need to find the slope of DE. Okay? To find the slopes of these two, we're going to take those values. So we'll take DE, which are our first two values here. We'll do this in blue. This will be slope of our line segment, the midpoints. D, we knew was at 4 and 4. And E, which is at 6 and 3. Our slope formula, I'll write it in once, and then from there on, we'll just kind of remember it, is y2 subtract y1 divided by x2 subtract x1. Okay. If this is coordinate 1, we'll call this x1, y1, x2, y2. So, y2 is 3, subtract y1 is 4, divided by x2 is 6, subtract x1 is 4. 3 subtract 4 gives us negative 1, divided by 2. So our slope is a half for that line segment. Okay? And then, that's the first part, we need to find the coordinate or the slope of, so we just found this slope here, DE. The next one we need to find is AB. Coordinates being 5 and 1 and 1 and 3. So we'll go down to the bottom. We already know our slope formula. Our coordinates were 5 and 1 and 1 and 3. This was our B. This is our A. So, y2 subtract y1. Well, we'll call this y2, this y1. That becomes 3. Subtract 1. What's the right coordinates? Yeah, okay, we'll try it up. And 1 subtract 5 for x2 and x1. 3 subtract 1 gives us 2. 1 subtract 5 gives us -4. When reduced, it's -1/2. So we just discovered that our slopes are the exact same for both line segments. Okay, let's change that view a little. That's a little better. So what we had to do is find the coordinates of two midpoints. Then we found the slope of our midpoints, and then the slopes of the line that, I guess, is parallel to it, AB. And we discovered that both slopes were the exact same, it turns out. Part B of this question says, verify that line segment DE is half the length of AB. Okay. So, yeah, we're going to go to another page just so it's a little clearer here. This is what we have. We have to verify that DE is half the length of AB. So we're going to use that distance formula that we know of. Our distance formula, if you guys recall, we take x2, subtract x1, square it, and then add it to y2, subtract y1, square it, find the square root, and we have the distance. So, point AB again. Point A, which is 1 and 3, and B, which is 5 and 1. Those will be our x1, y1, x2, y2. We'll do this one in red. So our distance will equal, proving that the distance of the new line segment is half the distance of AB. So x2 was 5 minus x1, which is 1. We square it. Plus y2, which is 1. Subtract y1, which is 3. And we square it. Then we find the root of 5 minus 1 is 4. So we'll square that. Plus -2 squared. And this is all square rooted. 4 squared is 16. -2 squared is 4. And we end up with root 20. Okay? We can solve that, but what I'm going to do is I'm going to try to find the other one and then see if we can verify from there. The other values that we had, we've already done the distance formula, so we're okay to continue with what we have. Our points were 4 and 4 and 6 and 3. Okay? D, if you recall, we solved in the first one, 4 and 4. And E was 6 and 3. So using that distance, that same distance formula, I think that's the same color. X2, well X2 is 6, we'll say, minus X1, which is 4. Then we'll square it, plus Y2, which is 3, minus Y1, which is 4. Then we'll square it, okay? D will then equal, I'm going to change the color of that, square root sign. I think that might be more towards it. That's better. 6 minus 4 is 2. What's 2 squared? 4. Plus 3 minus 4, -1 squared is? So we get root 5. Okay? So we're going to have to actually equate these because we haven't personally worked with radicals and we really don't get into it until grade 11. So we're going to use a calculator to actually solve this. I got no clue where a calculator is on this computer.
Search it.
Where? Oh, right there. Boom. That was easy. Okay.
AB is 4.5.
Is this a square root here? There you go. 4.47. 4.47. Whoa. What's going on here? 4.47. And our other one, 2.23, which is roughly, except for a bit of rounding, there end up being about half of the other one. Okay? So if you notice, one question took us quite a bit of work, especially this first page here. Took us quite a while to prove all of this.